Yeah, the 5.8, I think, let's say now just imagine, let's say, I will explain another example, right? Then you can easily understand, right? Just think about your classroom, right? Maybe in your classroom, just think about, let's say, 8 males and 6 females, right? So the first question, we need to select one representative. Either he is a male or female. There is no any condition, right? So is there is no any condition male or female. We consider all these population as a together, right? All the 8 plus 6 together, we are consider one group, one pool of students, right? From this pool, they are selecting. We need to select one representative. Means maybe there are altogether 14 ways, right? 8 plus 6, 14 ways we can select, right? So 18 ways we can select the one representative. That is the meaning of that one. It means that representative may be the male one, male two, male three, up to male eight, or female one, female two, female three, up to female six, right? So this is a population, right? M1, M2, M3, up to M8. Also F1, female 1, female 2, up to female 6. So altogether we have 14 options. Maybe he is the representative, maybe he. Or likewise, we can select the representative in 14 ways, right? So altogether 6 plus 4, 8, we have 14. That is the answer for the first question, right? Why? There is no any restrictions. But the second question they are telling, definitely, now the second questions, we need to select two representative, one male and one female students, right? Our representatives are now two representative. We need to select two representative, right? One male and one female. So in that type of scenario, what will happen? From these 8 male students, we need to select one male students, right? Let's say M1, M2, M3, M4, M5, M6, M7, M8. Here, F1, female, F1, F2, F3, F4, F5, and F6, right? Now, if you want to make the male and female, let's say, if I take, let's say, I am taking first male as a batch representative. With this first male, I can take this is one group, male one, M1, F1 is one group. Maybe sometime M1, F2 is my one group. That is also possible, right? With male one representative, I can create 6 combination of female groups, right? So that is the thing. With male one, I can create female one also. Male one, female two. Male one, female three. Likewise, with male one, I can create 6 groups, right? So altogether 6 possibilities, right? With male one. Similarly, now if I move with male two also I have these number of possibilities, 6 possibilities, right? Similarly, for male 3 also the same possibilities. Male 4, male 5. So altogether 8 times 6. So that is 48. This is a normal way we can find out the answers, right? If you apply the equation, yeah, I'm explaining the second question, right? The B part, right? So now this is the normal way. This is how we normally find out the answers. If you utilize the equation, we have 8 male students. From these 8 male students, we need to select one male students. Multiple by 6 male students, we need to select only one female students. So 8C1 into 6C1, that is the answer. So 8C1 is equal to 8. Multiple by 6C1 is equal to 6. 8 into 6, 48, right? The third question, we need to select one president and one vice president. There is no any gender, right? So that's a common. So they are not mentioning any gender. So they are telling we consider altogether 14 students pool, right? From this 14 student pool, we need to select one president and one vice president. So it means how many ways we are selecting the presidents? 14 ways, right? So now how many ways we are selecting the vice president? Already if we select one guy as a president, we cannot select the same guy as a vice president, right? So now we can reduce for the president, we have 14 options, but for the vice president, we have only 13 options, right? Because already we select one guy as a president. We cannot select the same guy as a vice president as well, right? So now what will happen? 14 into 13 times. This is a normal way, right? So if you want to utilize the equation, initially the student population is 14. From the 14 student population, we need to select one student, right? Then take the multiplication product rule. For the vice president, only we have 13 students. From these 13 students, we need to select one students, right? So 14C1 into 13C1, 14 into 13. So the answer is, this is the same answer for both questions, right? This is how we can find out the answer for the first question, right? Now I will explain the next question, right? So it means it's very difficult to understand, right? These concepts. That's why I'm telling, right? Try to understand here what I'm telling. Okay, now just read this question. Now just read the 5.9. There are 4 bus lines between A and B and 3 bus lines between B and C. Right? Just think about A is a particular town, or maybe A is one district, right? B is another district, C is another district, right? Just think about A, B, C. There are 3 places or 3 districts, right? A, B, C, 3 districts, maybe Ampara, Porterville, or Batticlo. Just think about A, Ampara, B, Batticlo, C is Colombo, or whatever, right? C is Colombo, okay? So now what they are telling, let's say, bus line in the sense, just think about the bus routes, right? Bus line in the sense, between A and B, let's say from Ampara to Batticlo, there are 4 routes are there. They are telling from Ampara to Batticlo, uh, there are 4 bus lines between A and B. So what they are telling, if you want to move from Ampara to Batticlo, there are 4 different routes are there, right? 4 different roads you have between Ampara to Batticlo, right? Now they are telling from Batticlo to Colombo, there are only 3 bus lines. 3 bus lines between, right? Batticlo to Colombo. If you want to visit from Batticlo to Colombo, only you have 3 different ways, three different routes, right? 4 bus route between A and B, 3 bus lines between B and C. Now what they are telling, find the number of M ways that a man travel by bus from A to C. The first questions, from A to C by way of B, right? What they are telling here, the first question, one guy need to travel, right? One guy need to travel from Ampara to Colombo, right? This is the question. One guy need to travel from Ampara, from A. Let's say we will take from A to C, one guy from travel from A to C by utilizing B, right? So it means one guy move from Ampara to Colombo through Batticlo, right? How many possible ways he can select? So that's the first question. How many different ways, different routes you have? How we can find out? Tell me. Okay, now we will take, this is a A1 route, right? This is A1 route. Let's say we will put differently. Okay, maybe this is a R1, R2, R3, R4, right? Here, maybe R5, R6, R7, altogether 7 roads, right? Now, how we can find out the answer? Someone need to travel from A to C, Ampara to Colombo through Batticlo. How many ways he can travel, right? How we can find out the final answer, right? First thing, we need to take how many routes they can travel from Ampara to Batticlo. Then take the multiplication of how many ways they are traveling from Batticlo to Colombo, right? From Ampara to Batticlo, we have 4 routes. From these 4 routes, we need to select only one route, multiple by. From Batticlo to Colombo, we have 3 routes. From these 3 routes, we need to select only one route. So 4C3 multiple by 3C1. So 4C3 is equal to 4 factorial over 4 minus 1, 3 factorial into 1 factorial. So 4C1 is equal to 4. 4C1 is equal to 4. 3C1 is equal to 3. Altogether 4 into 3, 12 ways, right? So now I will explain what are these 12 ways, then you can easily understand, right? So what are the 12 ways? One guy select R1, route 1. Let's say from Ampara to Betiklo, they are using road 1, maybe from road 1 to road 5, right? R1 to R6 also possible, right? Road 1 to R6, road 1 to R7. This is three ways they are selecting. Another way, if we select R2, R2, R5, R2, R6, R2, R7. These are another three ways, right? Another three ways, R3, R5, R3, R6, R3, R7. These are another three ways. The last three ways, R4, R5, R4, R6, R4, R7. So these are another three ways. Altogether, 3 plus 3 plus 3 plus 3, 12 ways, right? This is how we are manually find out the answers. But we don't need to manually find out the answers. By just utilizing the equation, you can find out easily, right? Hope you can understand, right? So this concept is more important, right? Maybe while you are creating some algorithms, or maybe while you are creating some shortest path algorithms, so maybe it's up to your final year research, right? Let's say if you are creating some of that algorithms, maybe you can utilize these and graph theories to find out shortest paths, right? Maybe this theorem is applied in Google Maps, right? So maybe if you search a location, let's say if you navigate the location between A and B, it will find out all the possible ways and they will find out the shortest pathways, right? So for find out all the possible ways, they are applying these combinations theories, right? These are the basics. So already they have maps between A and C. Among these maps, they will find out all the possible roads. Based on all the possible road, they are generating all the possible combinations, right? This is the thing happen. So the answer is 12 for the first question, right? Now, now we will move for the second part, right? What is the second part? First part, one guy need to travel from A to C the way by B, right? The second questions, round trip from A to C, round trip from A to C by way of B. So what do you mean by round trip? So the second questions, one guy move from A to B, B to C, again, right? From here A to C, again he need to reach A, right? Moving from A to C throughout B, then from C to A. Did you understand? So what they are telling, round trip in the sense we are moving from A to C through the way of B. Again, we need to reach A. This is we can call round trip, right? Now they are telling how many ways we can do a round trip between A and C. How we can find out how many ways we can achieve from A to C. If you want to achieve, if you want to complete the tour from A to C throughout the B, how many possible ways? Here we have four ways, here we have three ways. So altogether, maybe 4C1 into 3C1, altogether 12 ways. Again, we need to find out C to A. From C to A, C to B, we have three ways, 3C1 into 4C1. Here also 12 ways. The important thing here, for the round trip, we need to take the multiplication of from A to C into C to A. So altogether 12 into 12. So here A to C 12 ways, multiple by C to A 12 ways. So altogether 144 ways we can complete this round trip, right? Okay. Now, the third question, that is more important compared with the second one, right? What they are telling in the third question, right? What they are telling. So, second question, we are doing the round trip, right? in the second question, what will happen? Let's say if you are using, let's say one guy using from R1 and R5, again, he can use R5 for the return journey, R1 for the return journey, right? But the second question, the third question, what they are telling, right? Round trip from A to C by the way of B, but without using the bus line more than one time. So it means, let's say, if you are moving from A to B throughout the R1, you cannot use the same line while you are returning, right? So what is the third question? The previous question, maybe you are using A to B road 1, B to C road 5. You can use the same line for return journey also. C to B also road 5, B to A also road 1, right? The same road for your journey as well as while you are return, you are using the same line. But now the third question they are telling, if you are utilizing one road from A to B and B to C, you cannot use the same line again. So for the return journey, you can use the different lines, right? So now how we can find out the answer for the third question? Tell me how we can find out the answers. So now first we need to think about, if you want to travel from A to C, what are the possible ways? For A to B, we have four options, right? So we need to select 4C1 multiple by, from B to C, we have three options, 3C1, right? So altogether 12 ways. But for the journey of C to A, what will happen? From the journey of C to A, already, right? If you look at that return journey, right? Already, right? One road is we utilize, right? Previously, from B to C, we have three lines. So, okay, just think about we are using R5. Now, for the return journey, we cannot use the R5. So, only we have remaining two roads, right? So, from C to A, if you want to think about C to A, so the C to B, we have only two roads, right? 2C1. Then from B to A, previously we have four roads, but we already use one road. So, we cannot use the same road again. Now we have three roads, so 3C1. So 2C1 into 3C1, it is equal to 2 into 3, 6 ways. So previously, so the round trip, for the round trip, A to C multiple by C to A because of product rule. Right here for A to C, we have 12 ways. C to A, we have 6 ways. So altogether, 72 ways, right? So 72 ways only we can make, right? So the answer is 72. So these are very, very difficult question. Difficulty in the sense the understanding is mandatory, right? So you can write this type of map. If you are utilizing one road, again we are utilizing the same road. It means for the return journey, we can reduce one road. That's the theory behind this. Because we cannot, this is like a without repetition, right? We are not using the same road again, right? So that's why we are taking this one as a 72. There are a lot of exercises are there, right? Yeah, I try to do some other exercises, right? Okay, today the remaining time I try to explain some other examples too. Then rest of the things you can complete yourself, right? Try to do yourself. Try to understand. If you not understand, discuss with your friends. Even no one know, please let me know. Then I will explain, right? For the remaining questions, right? Yeah, we will move for the next one, right? Okay, the next one. Mm, if you want to tell something, just turn on your mic and let me know, right? If you don't understand, please let me know. Just turn on your mic, right? So this is the third question we discussed, right? So the next question, yeah, yeah, this is a theory question, right? Explain the difference between permutation and combinations. So you can explain with the help of give the priority for orders and not giving the priority for orders, right? So now they are telling P 7 comma 3. So it is equal to 7P3, right? So maybe we can write different ways. 7 comma 3 means the meaning of this one 7P3. So 7 factorial over 7 minus 3 factorial, right? 7 factorial over 4 factorial. So 7 into 6 into 5 into 4 factorial. So that is the answer for this one, right? 7 into 6 into 5. So likewise, you can find out, right? So I will explain only the complex questions, right? So you can do the simple questions, right? So these are very, very simple, basic questions. You can do it yourself, right? Okay, now I will explain this question, right? Okay, find the number of n distinct permutations. In the question, they are clearly mentioned permutations that can be formed with the letters of the words, right? So the first word, those, right? So now how many, okay, now they are telling how many distinct words we are generating by utilizing these letters. For the first question, right? So the first question A, right? So there's a word those, right? So here how many letters? There are 5 letters. N is equal to 5. Now they are telling by utilizing the letters of this word, it means all the letters of the word, right? So what they are telling here, we have 5 letters. By using 5 letters, we need to generate the words, right? Also, the important thing here, each letter is a unique letter. So if you want to apply the permutation, the question is NPR. So, right, 5 factorial of 5, let's say NPR in the sense 5P5. 5 factorial over 5 minus 5 factorial, that is not factorial, it is equal to 1. So 5 factorial. So it means we are generating 120 words, right, for the first question, right? It's easy to understand, right? The second question, what they are telling, utilizing this unusual. The word is unusual. So if you look at this word here, 1, 2, 3, 4, 5, 6, 7 letters are there. 7 letters are there. Among these 7 letters, how many letters are same letters repeat again? So U is 1, 2, 3 times occurred U, right? Others are unique letters. So this is one time, this is one time, this is one time, this is one time. So you occurred 3 times. So if you are utilizing the letters of this unusual word, so how we can create permutations? 7 factorial over 3 factorial. So this is the answer for the second one, right? Third one, sociological. Sociological also, we need to same. We need to count how many times occurred each words. Altogether, 2, 4, 6, 8, 9, 10, 11, 12 words are there. 12 letters in the word sociological. Here, how many O's we have? 1, 2, 3 O's, right? How many C's? 1, 2 C's. How many I's? 1, 2 I's. How many L we have? 2L. So here, so this is one time. S one time. C is one, 2 times. C. I one, two, 2 times. I. O already we mentioned. L is 2 times. G is 1 time. G is 1 time. A is 1 time. Right. So altogether 12 letter means 3 plus 2, 5, 5 plus 4, 9, 9 plus 3, 12. So now the answer is altogether 12 factorial, 12 letters divided by. Oh, yeah, good evening. Yeah. Sorry for that. Yeah. So 12 letters. So we need to utilize all 12 letters. So 12 factorial over 3 factorial into 2 factorial into 2 factorial into 2 factorial, right? These number of ways we are creating the words, right? This is how we can find out the answers, right? 12 factorial over 3 factorial into 2 factorial, 2 factorial, 2 factorial, right? So this is how we can find out the answers, right? Okay, the next one. Okay. Okay. Yeah, the next questions. A class contain 8 students. Find the number of n samples of 3 size. Right. So it means there's a class contain 8 students. From these 8 students, we need to select 3 students. Sample size of 3. How many different ways we can select the samples, right? So 8C3, right? 8 factorial over 5 factorial into 3 factorial, right? 8 into, yeah, 8 into 7 into 6 into 5 factorial. Here we have a 3 factorial. So 3 factorial is 6, right? So 8 into 7, 56 ways we can make these, right? So that's a simple example, right? Sorry, they are giving different questions, right? Okay, the first questions, right? With replacement, right? I forgot, I didn't read the questions, no. So the class contain 8 students. Find the n number of samples of size 3 with replacement, without replacement. These are the two things, right? Okay, just think about, right? This question, maybe this question, they have some confusion, right? So we cannot find out whether it's a permutation question or combination questions, right? So they are not clearly mentioned this one, right? A class contain 8 students. Find the number of n samples of size 3, right? So from these n students, we need to select 3 students, right? From these 8 students, we need to select the 3 students. From these 8 students, we need to select the 3 students. So the first question with replacement. So with replacement in the sense, this is not a combination questions, right? Why they are telling with replacement? If it is a student, right? Right. If you form a group, we cannot repeat this with replacement in the sense we are selecting that one student. We cannot select the same student again, right? So maybe this is a actually this is not a combination questions, right? This is a permutation question. Why? They are mentioned with replacement. So with replacement in the sense, let's say I am selecting student one, I can again select the student one, again select the student one. That is the meaning of that one, right? So this is not a combination questions, right? Okay, just think about this way, right? There are eight students. There are eight students in a classroom, right? I need to select three students to answer some questions, right? Let's say there is a competition is going on, right? There are eight students in the panel. Sorry, eight students are participating in this competition. Just think about eight students participating in a competition. Then it's easy, right? There is a competition is going on, right? On these competitions, there are eight students are there, right? Here, 8 students are there, right? Altogether here we have eight students are there, right? If I ask one question, right? If I ask one question, right? Okay, for the first question, student one answering. Second question also student one answering. Third question also student one answering. That is possible, no? So if that type of scenario, what will happen? I just think about this type of scenario. Now what will happen? If I take a sample with repetition. Repetition means for all three questions, the same student can answer. That type of scenario, right? So that is what they are explaining with replacement. With replacement in the sense, right? I am selecting three students, right, to answer three questions. So there are some repetition in the sense I am selecting the same students to answer three questions. That is repetition. Without repetition in the sense, if one student answer for one question, he cannot answer the second question because already he provide the answer for the one question. So that is the meaning of without replacement, right? With replacement mean again and again I ask the question from the same question, same student, right? Now what will happen? Let's say from this eight student, I select one student. So how many possible ways I can select the first student? Eight ways. Second student also I can select eight ways because if I select the first student, second question also I can select the same student also possible. So for the third question also I can select the same students, right? So 8 to the power 3 is the with repetitions. Without repetition in the sense, for the first question, I can select 8 ways. But if the student answer for the first question, he cannot answer my second question. So now we have only 7 students. So from the 7 student, I can select one guy. So for the third question, already 2 students are answer my 2 questions. So I can ignore those 2 students. Only I have 6 students. From these 6 students, I can select one student, right? So 8 into 7 into 6 for the second question with repetition. So this is how we can answer these type of questions, right? The important thing here, you need to clearly read the question and try to understand. Then only you can provide the answer, right? Otherwise, sometime if you read the portion of the questions, if you try to answer, sometimes you do some mistakes, right? So keep in mind that one, right? Okay, now we will move some exercise question from the combination, right? A class contain 10 students with 6 men, 4 women, right? 6 men and 4 women. Find the number of n ways. Select a 4-member committee from the students, right? How we can find out the first question? There are six male students and 4 female students are there. We need to make a committee with 4 members, right? So the first question, there is no any condition, right? Condition in the sense it is mandatory to include one male student, so it is mandatory to include 2 female students. There is no any restrictions. What we need to do from these 10 students, we need to form 4 student community, right? This is the question. There is no any condition. We consider each student as a equally, right? So we have 10 students. From these 10 students, we need to make 4 students, right? We need to select 4 students to make a group, right? So if you are making a committee or group, it is always comes under combinations, right? So the formula NCR. Here n is equal to 10. From these 10 students, we need to select 4 students to make a committee, right? So 10 CP in the sense 10 factorial over 10 minus 4, 6 factorial into 4 factorial, right? I'm writing directly. I don't write 10 factorial over 10 minus 4 factorial. For rather than 10 minus factorial, I can write 6 factorial into 4 factorial. So the answer is 10C4 is equal to 10 into 9 into 8 into 7 over 6 factorial, 4 factorial, 4 into 3 into 2, right? Then 4 into 2, 8. Here we can cut down. This is 3. So altogether 3 into 7, 3 into 7, 21 into 10, 210 ways we are making the group, right? This is the normal question. The second question, if you read the second questions, they are giving some condition. We need to create 4-member committee with 2 men and 2 women, right? Now it is mandatory to select 2 male students and 2 female students. Now how we can find out the answer? Tell me. This is something different, right? This is a normal scenario without any conditions we can find out, right? Now tell me, they are telling some conditions, right? So now how we can find out the answer? So 4-member committee, 2 male and 2 female. Our population is 6 male students plus 4 female students, right? 6 men and 4 women, right? Now just think about, let's say, if we need to keep 2 men and 2 women, right? Here we have 6 men, right? So we need to keep 2 men and 2 women. How we can find out? Previously, we consider all students as the same equally. From 10, we are selecting only 4. There is no any conditions, either male or female. Now they are clearly mentioned from these 6 men, we need to select 2 men, right? So now from 6 men, we need to select only 2 men, multiple by from these 4 women, we need to select 2 woman, right? For 6C2 multiple by 4C2. This is the answer. So now what is the answer? 6C2, 6 factorial over 6 minus 2, 4 factorial into 2 factorial multiple by 4 factorial over 4 minus 2, 2 factorial into 2 factorial. We can cut down this 4 factorial, this 4 factorial, right? Then 6 factorial, 6 into 5 into 4 into 3 into 2 divided by 2 factorial 2, 2 into 2. So 2 into 2, 4. We can cut down this with this. So here, 6 into 5, 30, 30 into 3, 90 ways we are selecting. Did you understand? Okay, the next question. Okay, a box contain 8 blue color socks and 6 red color socks, right? Find the number of ways 2 socks can be drawn from the box if they can be any color, right? The first questions, they are altogether 8 plus 6. 8 plus 6, let's say 8 blue color and 6 red color socks, right? 8 blue color and 6 red color socks, right? The first question, we need to select 2 socks, right? We need to select 2 socks, right? First questions, they can be any color, right? There is no any condition. You need to select, uh, let's say inside the box, inside the box, it contain 8 blue color and 6 red color socks. We need to select 2 socks. There is any condition. Either It means any color in the sense both are blue color or both are red color, both are different colors. So there is no any condition. So the answer is 8 plus 6, 14. 14C2 is the answer, right? 14C2 in the sense 14 factorial over 12 factorial into 2 factorial. So 14 into 13 over 12 factorial, 12 factorial, we can cut down 2 factorial 2. So we can cut down here 7. So 7 into 13, 91 ways we can generate the combination. The second question, they must be the same color. This is a condition, right? So there is no any condition. We have 91 ways we are selecting the soxes. Now they are telling the two soxes must be the same color. Then how we can find out? So it means how many possible ways we are selecting, we are selecting, right? Both soxes are in the same color. So how we can find out the answers, right? Okay, tell me how you can approach this question. So first we can find out without any condition, we have 91 ways we are selecting the soxes without any conditions, right? If you want to find out how many ways both soxes are with the same color, let's say, just think about from this 14C, from this 14C2, we need to subtract a particular value. Then we are getting two soxes are with the same color. So what is the value? Let's say if we subtract, right, one socks with the red color, one socks with blue color, right? It means we are subtracting the combination with have two different colors. How we can find out? So if you subtract this one red color options and one blue color socks options, then we are getting both the same color socks. Do you agree with me? So there are possible combination, both are same color or each one different color, right? These are the possible combination we are taking. Both are same color, both are red color, both are blue color, or one blue, one red. These are the all possible combinations, right? To take the soxes, right? Now, already we know if we have a 14 soxes, if we can select two soxes, we have 91 ways we are selecting these two soxes. Among these 91 ways, we need to subtract one red color and one blue color options, right? If you subtract the value of one blue color and one red color socks options, remaining are same color soxes, right? So how we can find out one blue color socks and one red color socks? Let's say we have 8 blue color socks. From these 8 blue color socks, we need to select one, right? Multiple by 6 red color socks. We need to take one red color socks. So 8C1 multiple by 6C1. This is one blue and one red color options, right? So 8C1 is equal to 8. 6C1 is equal to 6. So altogether 8 into 6. 48 ways we are selecting one blue color and one red color. So now if I subtract the value of 91, if subtract the value of 91 minus 48, these are the two colors are the same color. So the answer is 43 ways we are selecting both the same color, right? So they are explaining here, right? So this is one way, right? This is one way we are selecting the answers, right? How we are find out the answer? All the possible combinations, maybe two colors are same color or one color, one with each different color, altogether 91 way. We are subtracting one blue color and one red color option. This is one way we can find out the answer. Another way, right? Another way, right? We have 8 blue color plus 6 red color soxes, right? Now the question is how many options we are selecting the same color soxes, right? Now another way, from here 8 soxes, blue color soxes, we are selecting 2 red color soxes. How many possible ways? Plus from six red color socks from six red color soxes. If you are selecting two red color soxes, so if you take the sum of this one and this one, we are getting the same answer of 43, right? So what is this type of? So now what I can do, I need to tell, if I select both red color soxes, how many base both blue color soxes I can take. All together I have 8 blue color soxes. If I take two blue color soxes, that is 8c two ways, right? So it means 8 factorial over 6 factorial into 2 factorial. So 8 into 7 into 6 factorial, 2 factorial 2. If I cut down this and these 4, so 7 into 4, 28 ways I can select two blue color soxes. Similarly, both are red color soxes in the sense 6c2. So it is equal to 6 factorial over 4 factorial into 2 factorial. So 6 into 5 into 4 factorial, 2 factorial 2. If we can cut down 3 into 5, 3 into 5, 15 ways. So altogether 28 ways I can select red, both are blue color soxes. 15 ways I can select both are red color soxes. The sum of 28 plus 15 altogether 43 ways we are selecting the two soxes are with the same color, right? It means what I'm telling here, we cannot say only one way we can find out the answers in the combination and permutation questions, right? It's depending on your creativity and it's depending on your thinking capabilities, right? So the first, previously I explained, we can subtract one blue and one red color one, then the remaining one are both are same colors. This is one way. Now what I am doing, I can get this, I apply the sum principle. How many ways I can select both are red colors and how many ways I can select both are blue colors. Get the sum of these two, also get the same answers, right? So what I am telling here, it's depending on your creativity, it's depending on your strength of your thinking capabilities, we can find out the answers, right? Any questions? Anyhow, you are getting the same answer, right? If you think in a correct way, you are getting the same answers, right? Any questions? Okay, we will start the set theory by next class, right? Also next class, be ready for the continuous assessment on permutation and combinations, right? Okay, the next question, 5.18, what they are telling, find the number of n of committees of 5 with the given chairperson that can be selected from 12 people, right? So let's say from the 12 people, find the number m of committees. It means how many possible ways we are making a committee with 5 people, right? From the 12 people, we have 12 people, 12 members. From these 12 members, we need to generate a committee with 5 people. So now they are telling, with the 5 people, a given chairperson. So what do you mean by the given chairperson? What do you mean by the given chairperson? So it means for this committee of 5 members, right? They are giving one chairperson for this committee, right? Now, how many ways we are generating this chairperson? How many ways we are generating this chairperson? So from these 12 people, we need to select only one guy. So 12C1 is equal to 12 ways we are selecting this chairperson, right? So for this committee, if we select one chairperson, we need to select another 4 remaining members. So how many ways we are selecting these members? 11 people, 11C4, right? So multiple by 12C1, this is the number of ways we are generating, right? So 12C1 multiple by 11C4, these number of ways we are making these committee. Okay, I will try to explain some difficult questions. What is that? Mm, okay, I will explain last question, right? Malicious problems. Okay. Mm, these are answers. Okay. Mm, okay, I will explain 5.6.0, right? I will explain 5.6.0, right? This is the last question I will explain, right? Just read the question, right? Just read the question. Okay. Okay, just I will explain this question, right? A woman student is to ten answer 10 out of 13 questions, right? Find the number of her choices where she must answer. So there are 13 questions are there, right? She need to answer 10 questions, right? There are 13 questions are there. She must need to answer 10 questions, right? A woman student is to answer 10 out of 13 questions. Find the number of her choices where she must answer the first two questions. Okay, tell me the answer first. Try yourself. So just think about inside a box. Just think about inside a box. There are 13 cards are there, right? Just imagine there are 13 cards, right? Each card contain one question, right? Did you understand my question? There are 13 cards. Each card contain one question, right? Now, among these 13 cards, she need to answer 10 questions, right? So now tell me how many ways she can select these 10 questions out of these 13 questions. Tell me. This is not in the question. Tell me how many ways she can select these 10 questions out of 13. Tell me. Here there is no any repetitions, right? So if we say one question, he need to provide the answer. So there is no any repetitions, right? Also, this is not a this is not a permutation, right? So you need to select one question, right? Then you need to answer, right? Now tell me, let's say from these 13 questions, how many ways he can select 10 questions? 13 C 10, right? Did you understand? Hello? So altogether 13C10, 13 factorial over 3 factorial into 10 factorial, right? So 13 into 12 into 13 into 12 into 11 into 10 factorial over 3 factorial 3 into 2, right? So here 3 into 2 6, here 2 times. So here 26 into 11, 26, 26, 286 ways, right? So she can select 286 ways the question, right? This is not the first question, right? So the first question, right? So from 13 questions, she need to answer 10 questions. Out of 13, she need to answer 10 questions. The first question, find the number of choices where she must answer for the first two questions. So how many ways she must answer for the first two questions? So how many ways he can choose and answer for the first two questions? So the first two question in the sense, how many ways he can answer? He can how many choices to answer for the first question? 13 ways, right? So altogether 13 questions. So the first question she can answer 13 ways, multiple by if she select one question in the first time, so the second time he has only for the second question only she have 12 questions, right? So 13 into 12 number of ways he can answer for the first two questions, right? So what is the answer? 13 into 12, 156 ways. Okay, the next question, the first or second question must not both. Okay, I think it's passed away for. Yeah, okay. Okay, yeah, time is past, right? So just take a screenshot of this question, right? Take a screenshot of this question, right? Do it as a homework, right? I will look at your answers by next class, right? Then I will explain this, right? Do it, take a screenshot or take a capture of this question and do it as a homework. Try to find out the answer. I will check by next class, right? Even I didn't share the lecture materials, right? So if you want, you can take the lecture. I didn't share these one slides. You can take a screenshot. I need the answer for this 5.60, right? So try to